following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Now, concentration cells, we just said that our electromotive force, right? So our electromotive force, or our voltage, right, is dependent on concentration. If you actually have the same species, right, we have a nickel ion concentration at the anode of 1.00 times 10 to the power of -3, and then at the cathode we have a nickel ion concentration of 1.00 molar, right? We have the same species, but in different concentrations at the anode, it will still generate an electromotive force, right? Because we see that there is a reading on the voltage. Now, what ends up happening is, let's actually take a look at each specific compartment, take a look at what happens in that compartment. So we have the anode oxidation. At the anode, we have oxidation taking place, right? Here's the anode. We should have oxidation taking place here. What's going to happen here is you're going to see your nickel solid, right? It's going to increase your ion concentration, right? It's going to give us nickel ions, right? And those ions, once they come into the solution, it's going to increase your concentration. Thus, at the anode, or where there's oxidation taking place, right, your ion concentration will increase. Now, at the cathode, where reduction is taking place, your ion concentration, or your ions you see are going to be taken up, right? Because there's a reduction reaction taking place here. So if your ions are being taken up here, your concentration is going to decrease. Okay, great. And eventually you're going to get to this point where you're going to reach your equilibrium constant, right? And at that point, as we said, there's going to be no net electron transfer, and you should have 0 volts. And that's exactly what we are seeing right here, 0 volts, right? And we can see here the concentrations are the same. Wonderful. Now, what we'll do is we'll actually, just to build a little bit more familiarity with the Nernst equation, we'll go ahead and we'll find out how we got this electromotive force, how we got this value here. Say you may have a question in regards to, in a concentration cell, you have one concentration here and another concentration here. What is the electromotive force? Say we didn't have this value here, we'll go ahead and find that now. Great. Oh, we actually have one more slide before then. Oxidation results, we just talked about this. Oxidation results in an increase in the aqueous ion concentration, right? And reduction results in the decrease in the aqueous ion concentration. Now, what about the standard cell potential? What would the value be for the standard cell potential? Well, since they're both exactly the same, right? Well, we know then that our standard cell potential is just going to be 0 volts. Okay, wonderful. Now we can go to the next slide and we'll solve for that. Great. We'll begin here again just with our Nernst equation, right? And if you recall, that was just negative 0.0592 over n, and that's going to be log, and perfect. This is going to give us our standard cell potential. What was it? Well, we just said that it was 0, right? And how many, there we go. And how many moles of electrons do we see being transferred? There's going to be 2 moles, right? So we can go ahead and write that in as well. Great. And what about our concentration here? it's going to be 1.00 times 10 to the power of negative 3. It's the lesser concentration, right? And that is just going to be over 1. Wonderful. When you go ahead and you equate this, you will get a value of 0.0888 volts, and that is what our reading shows. Okay, great. Now let's move on to our next slide. Now we're going to be taking a look at